Okay, so yeah, it's just gonna go over kind of the Azure OpenAI and the Chat Playground and its API. But I think for this one, I'll focus up on something called the embeddings model, right? Which is basically the building block on how you chat on or have prompts on your own data, right? Or your own documents, right? So I'll go pretty deep into that. Um, so it's this one is more for kind of like the developer, data engineer, um, and to see the tools that the Azure OpenAI offers, right? Where Dennis he was just showing like the connectors, cognitive search, with the SharePoint integration.
Right.
Here it's just kind of standalone, more raw, like the kind of the base building blocks, more or less, right? So you
Okay.
can build like more custom applications, right? Like
Cool.
like LLM. So okay, cool. So yeah, for those, I think everybody knows me here. So yeah, just I'm a Microsoft MVP, worked with SharePoint and Azure a ton, and active participant in this awesome TSPUG community. So um, so the agenda is really going over what is OpenAI and kind of going over the OpenAI playground, what are the models, and then you'll see API parameters, and then we'll go through kind of what embeddings, a demo, right? So it's a kind of a Python code application, right? I'll go over with. So feel free, like we're a small knit group, so feel free to interrupt and ask anything, ask me anything, interrupt me. I love dialogue. Okay, so with Azure OpenAI, right? So it's really taking what, OpenAI, like that we all know about ChatGPT, and having kind of access to their models like GPT-3 and GPT-4 to some extent, right? And able to deploy that at like more of an enterprise scenario, having like virtual network support, things like managed identity, role-based access, uh, a UI experience in the portal, um, etc. Right? So how that looks like, I'd say in the Azure portal. So let me ask this: have any of you guys played around with it, like 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 created an Azure portal and just play around with it to any extent? Any of you? No?
I did a talk at the AI Days end of September, which was similar to Dennis's cognitive search and OpenAI and pulling those two together. So that's sort of my only experience with it.
Okay, okay, cool. So all right. How about you, Bill? Any hands-on tinkering?
Okay, muted. Sorry. No, I haven't played much on Azure for a while,
Okay, okay, cool.
and I really am more interested in the refined products like the co-pilots now.
Right, right. Yeah, yeah, totally. So, okay, so this is kind of what it looks like deployed. Your pricing tier. Key thing is your endpoints, right? Your keys, right? And then you get your kind of URL endpoints. And your APIs. So hold on a sec. Let me just maybe it's yeah, here it is, right? So, that's like the base HTTP URL, right? So you can, and I'll show you in code with that in a moment, right? So um and then, pricing tier, networking. So it's just general public access. Of course, any enterprise scenario, you want to have private access and integrated to your corporate virtual network, and identity, all that stuff, right? But so so the real kind of more like finer grain configuration and management of the actual models is in this OpenAI Studio, right? the playground. So just to break it down, what it all starts off with are the models. Okay, so these are the models that are available and that you have to pick and kind of deploy. So there's GPT Turbo 16K, which has a higher token limit. Oh, this one looks new. GPT-4. It's not exactly the same as the one shown in OpenAI, but it has more capabilities. And then you'll notice like models that are text, Ada, Babbage, Curry, and Da Vinci. So just the takeaway here is notice like Ada starts with A and then B, C, D. So the the ones going from A to D is a higher level of capabilities, but the trade-off is cost and performance, right? So I think for the what we we understand of kind of with ChatGPT, you want to start off with kind of the Da Vinci model, right, or the GPT 3.5 Turbo, and so um, simply speaking, like, okay, what do we use for what, right? I would say for most practical situations, just go with this one and the four, but where like Ada is not as capable as the other ones, like it's just good for like general, sentiment analysis or text classification, like for example, if you have a bunch of like product reviews and or social comments, social posts, tweets, or whatever that you want to like say, okay, what under what kind of category or subject is this under, or what's the sentiment, positive, negative, etc. Right? So you probably use these ones because they're cheaper and faster if you're going through like a very high volume of data, but you're not like asking like very sophisticated questions or prompts and expecting a very sophisticated answer. So that's what how I would see it when you see this Ada, Babbage, Curry, and Da Vinci, right? And 3.5 GPT 3.5 and 4. Um, One thing that I will go through in a lot in greater detail is the embedding model. So this is not a model where you chat with, you ask questions or prompts or anything, but it's the basis of kind of having numerical representation of your documents or your text or your document paragraphs, such that they can be queried upon. And I'll get this into. So this is the model you definitely use on the scenario for like chat on your own private documents or corporate documents. Okay, so just take away here is the word embedding. Okay. Next we go here is once we take the model, we want to deploy it and make it usable. Okay, and so you just create, you select one, you deploy, you give it a name. There may be certain parameters as part of the deployment, content filtering, right? You know, and the model version, etc. And also what kind of token limit, rate limits for a certain amount of throttling. Okay. Um, so, because this is useful because, if you're deploying this and it's made for use, it can get expensive fast, right? So it's something to watch out for. So anyways, once we have the deployments, these are the deployment names. I just take it off the same name as the models, okay? And then we go to completions, then we can start um, we choose a model, right? This one here is really GPT 3.5, and and then everybody knows this, right? Like what is the capital of France, right? Very 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 simple, right? So that's one API call, and then that costs some money. So and then we got a lot here. So here, it, as you can see, it didn't really answer the question. Maybe I should put it a question, right? Because it was, you know, kind of filling up a pattern, right? It assumed it was filling up a pattern. So, okay, it's getting poetic here. So yeah, this is what I see. Like there's kind of repetitiveness, you know, as well. And we can do this. Let's see here. So it's hit miss. So okay. So here it's more intelligent, right? It gave Paris and as well as uh, other possible questions like Spain and capital Italy, etc. Right? So these are the API parameters are things that you want to play around with, right? To get it to do kind of what you want. Okay. So let's see here. So go with that, and then okay, but let's just see like other models, like how they behave, right? So the ADA, so the ADA model, right, is France. So that's pretty good. It was
Right,
pretty
just a quick
straightforward.
question.
Sure.
What's the context of this type of request? So you said the learning model is already configured with a context, or
Oh, okay, so the context, there's kind of no context. Okay, in this situation with this prompt here, there's no context really. You have to set up the context,
okay,
right?
so
By saying like, the context of this question is you are a geography teacher, and I am a student, and I'm trying to learn about the whatever a capital of countries.
okay, so that would be that part, and then the corpus of information, that is the internet.
Oh, the corpus of it is involves the internet. It involves kind of internet sources like Wikipedia, books. So from my understanding of just general reading and research, right?
So you're getting all
Up.
that by using the different different models then.
Yeah. So I think the one that's kind of more capable, like this, GPT-1, like GPT 3.5 and 4, they would have more more data, right? Like they source, like the internet, books, Wikipedia, public sources, etc. But the data only goes up to the year 2021. So that's kind of where the model has been developed and trained, is based on that corpus of data.
So
Make
it would know
sense?
how to program if you give it a programming request.
Yeah, it could, So okay, let's try this. Write me a JavaScript application to calculate I don't know, the area of a circle. Right. So okay, let's try that. So here, okay, so here it's kind of assumed many things. Okay. Let's see here. Let's put the temperature down here. Okay, let's see here. You are a programmer. Write me a. Okay, let's do that. Okay. Didn't quite work there. Okay, let's try different. Okay. If we go to, let's say, let's see here, the chat playground, then let's use like GPT-4, right? And let's see here. Okay, let's see what happens here. So here we go. And yeah, it's pretty neat right there.
It actually wrote an HTML page with embedded JavaScript.
Yeah. I bet you I can just, copy this, put in HTML file, open up in the browser, and, off we go, right? So, yeah, there you have it, right? So here in the kind of the chat playground, GTP4 being more capable, but let's do that. Let's go back to this one and do the same thing. So clear chat, and let's see here with this model. Okay. Yep, this does it much better, So I encourage you guys to play around with that. So let's see here. Okay, so just to talk about kind of these parameters, kind of what they are. I find that there's no like real hard rule or really good, like it's more of an art than a science, right? On what you would expect, like in what situations and what kind of text do I want to, play around with these like levers, right? Of something called temperature max length. So I'll just quickly go over it so that you haven't just a rough idea, right? So temperature is kind of like the more popular one, right? So between 0 and 1, it's about kind of how so 1 being how creative the response would be, right? And 0 being more deterministic, right? So when you're asking more like technical questions and you want more of a technical response, then you want to have it closer to 0. Okay, if you want it to be pretty like wordy and informative, right? If you're gonna do like writing a poem or stories or a rap song, then you would lean towards a value of 1. Okay, so it's all about controlling kind of the randomness of the words, right? That come from the response. And really important thing is the max length token. So if you guys don't know already, a token is really like when the model takes on like a bunch of text, right? It has to kind of tokenize and break it down, right? So each token is, represents like a syllable, of a word, like usually like up to 4 characters, sometimes, roughly sort of 4 characters. So, not let's see here, um, like number can be NUM and BER as a token, right? Spaces is also part of a token, right? So once you break this down into tokens, okay, so token is roughly 4 characters, right? Then there's a maximum amount of what can be uh, consumed and produced, right? Or the response, right? The number of tokens. So you can't just go in here and just like paste like a 50-page Word document. It's just not going to work, right? It has some, software constraints, right? Depending on the model. Okay. And also there's costs associated with that. So you got to understand kind of what's the appropriate amount depending on what you're trying to do. Now the thing is, you may think, well, I just want to have max length tokens of all the way. Why not, right? But that may have some adverse effects because let's see here. Like for example, a response can get too wordy, right? There's too much like randomness, too much what do you call it? Information that's just kind of like filler, right? So depending on what you want to do, and depending on the data you consume that you want to process, like you have an Excel spreadsheet of like unstructured data or just text or and then you want to consume them, then you want to play around with the max length token, and that again that has an influence on cost. Okay. Next is stop sequences. So don't clearly understand what how this behaves, but basically in the response, you want to stop at a certain point, right? Again, it depends on what you're asking, what kind of responses you may get, but you may ask for, okay, give me a list of items, but stop when a certain you encounter a certain word, right? Or for example, like a stop word, right? That may be, let's say, like negative, right? In that context, right? Like the word bomb, right? Or terror or something like that, right? So you may want to have that and just to limit that, right? So, and there you have stop sequences, right? Um, and also there's top probabilities, which is very similar to controlling randomness, right? From what I read, they kind of go hand in hand. And it's really taking a bell curve of the type of the next word that is produced, right? And which one it would choose with the model. So it has to do with that, some statistical bell curve, right? So it's similar to, in my opinion, it sounds similar to temperature, but mathematically, mathematics and statistics, it's kind of approached differently. Frequency penalty, reduce of repetition, which you saw kind of in the beginning, okay, and presence penalty, similar to limiting repetitiveness or the presence of things. Best of, right? So you may say, okay, well, generate 4 responses, but have the LM decide what is the best one to choose, right? This takes up more tokens, right? More processing power, because it's like behind the scenes, and it's not transparent to you, but you see like the like 4 possible responses, and it will choose. So maybe it helps with better accuracy in what you want to do, right? So okay, so next, having said that, right, really, I'm sure you heard of the word prompt engineering, right? So I think that, this is a good starter kind of template or approach, which when you want to do prompts, right? To help set the context, right, and have more accuracy. Because as you saw, like, what is the capital of France? It kind of drew out like a bit of a poem, kind of thing. So what I do whenever I work with like even Chat GPT is a popular thing is you are a SharePoint expert or SharePoint consultant, right? Or you are an Azure engineer or DevOps engineer. Do it and then write me a script, or JavaScript application code that does X, right? And and you can say respond in a format saying, okay, and please respond in a pretty format, let's say, or point form notes, okay, or respond in JSON format, okay, or YAML. You can even ask that, and it works pretty well, to be honest, right? Next, you can say, and I don't really use this, but again, this is more for like if you're doing more creative content, right? Like stories and songwriting, etc., right? Or a movie script. You can say, okay, present in a tone that is comical, funny, or or in a tone that is aggressive, harsh, cold, things like that, right? And then you can also state kind of like to add context. Okay, what is the main objective? Okay, the main objective is, I want to write a calculator, right, for 6-year-olds or 8-year-olds, right? And then what I find is what I encourage this as well is applying restrictions, right? So, you may start off with something simple, like just act as a rule, do, and then you start to see like stuff responses that don't make sense. That's not relevant. So you can say apply restrictions saying, do not show me any code that relates to, in the context of JavaScript programming. I don't want to see anything with React, or with Angular or TypeScript or something of that nature. So having these together, so there's other like a lot of nifty prompt techniques, but anyways, I think this is for this type of session in this audience. I think it's really good to have this type of kind of a template in mind. So any questions, comments? Any of you tried this approach? Okay, cool. And okay, so going to here, so with the prompt engineering in mind, let's see here. So when you're doing the chat playground, you want to apply some of that prompt engineering, right, to set up your context. So let's just take the out of the box examples right here, right? And I think, and they're really good too. Say you are a so here you give a system message, right? So these system messages, pertain to your chat session, like end to end, right? So your string of kind of prompts, okay? So you are IS chatbot, so you're telling them what's their role, right? And they're being specific to 2022 year tax returns. Provide concise replies, so like the format or the tone of the response. Answer questions truthfully. And then restrictions such as do not answer questions that are not related to United States procedures, et cetera, right? And maybe because you're an expert in this area, that there could be some ambiguity that you want to clarify, right? Such as certain laws or something that that your audience will ask upon, and you just want to influence and manipulate the model to give it more weight towards your just kind of a certain answer on a certain subject, right? So as they have here, right? So that's the system message. And then you have something called user messages or one shot. So here, this also helps with the kind of the weight and the way that it responds, right? So for example, if in the chat session, if someone were to ask, when do I need to file my taxes by? And you don't want the LLM to, respond in a way that's that could be possibly like go on a tangent, okay? Because it could be that in the chat session they ask a whole bunch of like different types of questions, and that also helps with the establishing the context of that chat session. So to really kind of like what we call ground, or or not the chatbot or the LM not to kind of quote unquote hallucinate, is that you want to anchor them or ground them. Say, when do I need to file my taxes by? And then you have this type of more concrete answer, right? So it'll gear towards this type of answer, and then you can keep on adding other examples, right? Like go on and on. And it's probably from experience, right? You would see a history, a log of everybody asking certain questions, and you see a pattern, and you don't want to and you see the responses. So this is where you kind of do that, fine tuning, it's and calibration, if that makes sense. So any questions here? So okay, so clear that. So if we do that, and let's just try that out. Let's just say when do I need? So yeah, it brings that out, right? So you can ask like, if my income was 100,000, let's say in the state of California, how much taxes do I pay? Respond. Okay, let's try this. Respond in JSON format. Okay, let's say let's see what happens here. So first calculation. Okay, so here it probably had a system message. You know what? I asked this question like a couple of months ago, and I got a pretty good answer in state. And okay, let's try this. Okay, here we go. So I guess because I added respond in JSON format, maybe it got confused, right? So and it's probably expected depending on the system message, how it really kind of sets the scope in the context, right? So here you get your federal income, California state income, etc. So that's pretty cool. Okay. Any questions? Okay, cool. So on to the next topic, right? So prompt engineering. So just briefly, this is kind of new, the DALL-E, the image generation. So this is what I played around with. Like I was kind of doing some like landscaping the last few months, like fencing and interlock. So I was curious, like what kind of useful images can it bring, like in terms of like any designs, right? So um, not what I was expecting, but it's still very like a picture, right? Than like a schematic. But a lot of the popular examples is like, show me a picture of a cat in space, right? And then you see this cat in a astronaut suit and stuff like that, right? So, so these are just some fun things, right? You know, like to do nice logos for corporate. I don't know, didn't really look that great. But anyways, that's just a really quick thing about the DALL-E. Of course, there's an API for it. Okay, so why don't we just go into some kind of code. So how does this look like in code? Okay, so I have a few examples here. So okay, so one thing is whoops. So okay, as you see here, okay, you can go view code and boom, it gives you the code that you can use. You can choose Python, curl, JSON, even C#. So it kind of sets you up there, right? So I would say for the language of choice, when you want to build like custom like LLM, large language model applications, I would say go with Python, okay? Because that's really the language of choice, especially in the data community. And this is pretty like, the whole AI is very data oriented, right? And you'll see lots of examples in Python. So, as some of you know, like C#.NET is really my roots, right, of development, like, and I really like C#. But you don't really see that many examples, right, of C#. And then when you want to use, in GitHub, like sample code or sample projects and, or import them as either their modules, they're most likely Python. So, so I've been getting really into Python lately. Not too bad of a learning curve, but it's always about the nuances of, yeah, just the dev tooling and VS Code and, the syntax and all that stuff, right? But not too bad, but it's not like you can figure it out in a few nights or something like that, right? So okay, so let me revert to example here, right? So so let's see here. Let's run this one. Okay, so is this, did I run this? Okay, so here is the chat completion, and you know, you got to import the OpenAI kind of Python package or module, right? And then say kind of what the API is. Here's my endpoint that I showed earlier, what version, and also your API key or your secret. Okay, and this is just in an environment variable. And then very simply, you know, call the API, right, based on these parameters, like which is the model deployment, okay, and the prompt here, right? So this is in a format which has the system message and also along with your prompt here, right? So what it returns is that was created, prompt in, you know, content filters, if any are applied or flagged or anything. And so here's the response, right? So I'm not a real tax information, but anyways, that's the response, okay? And we can see here the prompt tokens and the completion tokens, okay, and the total. And so this, you need to know like these numbers to figure out what the pricing of this API call is, right? So I'll get into that in a moment, right? On exact pricing. Any questions so far? So again, a scenario, maybe a practical use case that one can do is if they have an Excel spreadsheet or like just a log of unstructured data, let's say product reviews, okay, and you want to go through each one of them, and you know you want to say, okay, here's some text, you know, within the token limit, and tell me what's the sentiment of that, right? And you just loop through. So that's kind of how you can use this API for like going through like rows of data. So the next thing I want to go to is now, okay, now the embeddings model, right, which is really powerful. So again, this is the basis of, you know, the basis of having that scenario of chatting on your private documents, okay? So an embedding model is converts like, you know, text images, right, into a vector representation. Okay, so basically a vector of a number, so numerical representation, right? And so by doing that, you know, you can compare two pieces of text and figure out their similarity, right? So here I pulled this out from this website. Okay, so you know, here you have let's see here, a source sentence. Okay, machine learning is so easy, and then you want to compare with these three sentences. Deep learning is so straightforward. This is so difficult, like rocket science. I can't believe how much I struggled with this. Okay, now using the embeddings model, you take each of these sentences, 1, 2, 3, 4, and then you can put them as a vector representation. Okay, I'll show you that what that looks like in a moment. And then with the embedding model, okay, you do something called cosine similarity to compare this source sentence and these three other sentences. So 0.623 is that cosine similarity value. It ranges from -1 to 1. Okay, 1 being similar, -1 being opposites. Okay, and 0 being like not related. Okay, so it makes sense here, right? So deep learning is so straightforward, is pretty similar to machine learning is so easy, where the other two has similarity values of of less. Okay, so so the way I understand this is that it's the because the embedding model is a language model. Okay, it knows how to process natural language. Okay, so by the vector representation, it knows the context, the semantics, right? Versus like maybe I don't know, traditional or like early generation, like text searches. It's always based on, more so with keywords, right? Or a set of keywords and how they're positioned, what keywords are next to each other, and things like that, right? So here, because machine learning is so easy, right? I think that it would know that it's talking about um, AI, right, rather than a learning machine, let's just say. You know what I mean? If you take it to uh, like we call it like, yeah, just taking it literally, yeah, the word literally, okay? And then deep learning, okay, well, what's deep? Again, that's related to artificial intelligence. So there's similarity with these, where these ones, it's less similar, and so that's the whole idea behind the embedding model and how we use that. Does that make sense? Okay, so let me go through a code demo. Okay, so cosine similarity, I just want to go through this actually. It measures the similarity between two vectors of an inner product space measured by the cosine angle between the two vectors and determine whether two vectors are pointing in roughly the same direction. It is used to measure document similarity in text analysis. Okay, so what does a vector look like, right? So let me see here if I can grab something here. So here, so we'll get into this, but I'm just jumping ahead so that you have an idea what the heck is a vector, because I'm going to keep mentioning it. So if I go file new, let's see here. Okay, I'll just paste it down here because I don't want to lose that. So here is a vector or array. It's of like literally thousands of numbers. Okay, so that's how a vector, and it's not even all of it. Okay, it got truncated. So a vector can have thousands or tens of thousands of these numbers. Okay, and so just for now, just that's what it looks like. Okay, but okay, let me proceed with the demo for this one, right? So okay, so here's a embedding model. So in Python, if you guys know, there's something called a Jupyter Notebook, which I find is really cool. Let's see here, sorry. Oh yeah, whoops, I gotta do this. Okay. Oh yeah, right here, okay. So we'll go through this one by one. Let me go back to my slides here. So if I wanna, so there's that. Okay, so I just want to give you a high level so you can help follow along, because I don't want to like just talk all code and lose you guys, right? So the idea here is, let's see here, if I can just shift, okay, can't do slideshow mode, slideshow, because it keeps jumping into my other monitor. Oh, okay, here we go. Primary monitor. Okay. So, okay, step one, right? So in this Python code, it's just going to prep up the HTTP call with the endpoint and the API key. And then I have a CSV file called like of US bills. Okay, so it's just a bunch of text. Okay, it's a document like US laws or bills or something like that. Okay, and what we're going to do is we're going to take a vector representation of each of these text small documents or paragraphs, and ask a question on them, right? And we'll find the best which the closest matching document to that question. Okay, and then the third step is to take the data, kind of cleanse it, normalize it, find the token count of each US bill document. Okay, but we in this example here need to filter out US bill documents that are greater than 8,192 tokens because of the token limit of the model, right, that we're using. Oh, and also there's a token limit to the embeddings model too, right? So and then we'll look at the 20 bills, like US bills that are that have been like that's useful for this demo. Okay, and apply, and for each of those 20 bills documents, we're going to apply the embedding open API call, so that each one has a vector representation, which I just showed you, right? And then save it into a CSV file. And then next is, okay, now we're ready to search against the vectors, okay, the 20 vectors, and say, can I get information on cable company tax revenue, okay, and then return the top 4 similarities, okay. So this query will also be vector, like turned into a vector, and then again, in the as I mentioned before, it'll take a cosine of the question vector and against the vector of all those 20 bills, okay, and kind of like, you know, as you know, in cosine, like they quote unquote, the angle, right, between the two vectors, how close they are, right? Does that make sense? Okay, so we'll just go through the demo, the Python. Okay, so so if this cell right here in the Jupyter notebook, if I run it, okay, so that's the cool thing. You can break down your script, you know, and then chunk it out in pieces and then output them, you know, per like cell or chunk, you know. So here I get my request ready. This is basically asking, okay, what are my deployments, model deployments, and print it out the response. And here I just see like the text query 001, etc., text ADA. Those are the models I have. So that's just kind of kicking the tires, right? Just to see that the you know, I'm able to access the model, and you know, the API key works and this and that. So it works. Okay. Next, we're going to read that build some data CSV file. So let's just show you what that looks like. Okay, so the file is bill ID text. Okay, so here's that the document, just a summary of it, and then the title of the US bill. Okay, but the text has a bunch of the documents. Okay, so that's, you know, that's the input file of this demo. That's what it looks like. Okay, so I run that. We run it. df just okay. Output me the value of that variable. So df stands for data frame. Okay, just like, you know, rows of data. And so that's what we have. Okay, just like that CSV file. Here it's going through that data cleansing step, right? Data normalization, you know, remove all instances of multiple spaces, anything that's with /s, you know, clean it out, strip it out, all that stuff. Okay, so that it's easier for the the model to work with. Okay, here like any like carriage returns, you would see /n, take them out, and then here kind of normalize that text. Okay, which is this function right here. So basically the text column, right? Go to each one and just normalize that text. Okay. Next is tokenizer. Okay. And go and find out the number of tokens, right, for each of the bill, right, the bill document. Okay. So df bills text apply tokenizer, and then it's basically create a new column. Okay. And write down the number of tokens. And then right here, now we're going to filter it out, right? So in df bills, get me the documents that are number of tokens less than 8,192. Okay, so you can run that, and the length of df bills is 20. And here we can run the text. So here we have the 20 documents. Okay, 0 to 19. The full kind of document is kind of truncated. So the data is prepared, okay, for the purposes of this demo. Now, let's see here. So df bills. So this is the number of tokens that was produced, right? So for this one and this one right here, okay, that's what that looks like. Okay, so now this is kind of the heart of the script here, which is calling the embeddings API call to the Azure OpenAI. So it's using the model text embeddings ADA 002, right? And it's going through each build document, okay, and then apply the embedding and output that into a new column called ADA v2. So this is where the vectors will go to, okay, and then save it to a CSV file. Okay, so let's run that. So as you can see here, this takes some time, right? Because so there's a lot of number crunching. So I get a permission here because I have the document opened, but anyways, this is what it looks like. Okay, so if we look here, it produced this column and then put all the vectors representations right here. Okay, so this is a vector representation of the data that's here. Okay, and yeah, it keeps on going, but it's a lot. Okay. So we got that. Any questions so far? Hopefully you guys are able to follow. If I lost you, feel free to ask. I can clarify any points. Okay, cool. So the next one we have tokenizer. Let's see your sample encode. So this is just saying, okay, for the df bills, the text 0, like the first document, how many tokens does it have, right? It's just showcasing like the tokenizer function, how that works, right? Okay, and then here is the very final step, which is let's search on those 20 bills. Okay, so we're gonna call this search function. Okay, search based on df bills, like the data frame, and ask this question: can I get information on cable company tax revenue? So what it does is it prepares the it calls the embedding model and the user query, which is that question, and then it turns that into a vector. Okay. And then what it does is for the data frame for the column ADAV2, because this is the column that has all the vectors. Okay. This one right here. And it's going to do for each one, do a cosine similarity based on the embedding, which is the embedding of the question, right? The user query, the search question, let's just say, right? And it will calculate the similarities and put them in a new column called similarities. And then here it's going to sort the similarities.
Showing pictures that match.
Oops. And then print them out. Okay. So let's run that. And so what we have here is because okay, so you see here top N4. So show me the top four similarities, and we have this one 0.819. Okay, based on this document, and let's see here, and so that document is really this one right here. Okay, so yeah, this document talks about broadcast television, which is related to cable companies, and yeah, so, and it has mentions tax revenues. So so that's where now. The thing is, it didn't like actually give a intelligent response like in a chat-based application, right? But the point of this is that it's just comparing similarity, right? Semantic similarity between two pieces of text, right? That's what the purpose of this demo is, right? So just kind of very bare bones and kind of yeah, very simple, rudimentary. So
Roy, question for you.
Yeah.
I've got a scenario that I've been meaning to get to, which is part of the people search topic that I've mentioned that I can be presenting in Chicago in a couple of weeks.
Yeah.
I wanted some sample data, and I figured ChatGPT was the best place to do that. And is there, I guess, two questions. One is there a similar API? Is it the same API if you want to hit the public ChatGPT service rather than the Azure OpenAI service? Because then you're not paying for the queries. And then the second part is I literally want to create about 1,000 staff profiles of people working at a fictional company, kind of a Contosa type of example.
Yeah.
As you're sending it through the API, like here you're feeding the document and getting an analysis back. We're doing it the other way and saying, hey, I want to feed you a little bit of criteria and you give me a document back. Is there a concept of the chat session history so that it doesn't just keep feeding you the same thing back as part of that? Because I don't want 1,000 that look almost the same.
So like, okay, so to me, that would be 1,000 API calls, right? So you want to get like these Contoso employee, profiles, let's say, right?
Yeah.
So, let's see here. And then, yeah, for each call, you don't want them to be similar to one another, right?
Right.
Yeah. That's
like, does each call effectively represent a new conversation, or is there a memory like you have in the chat interface between those?
Yeah. Okay. So let me try to answer that. So in terms of the chat bot, okay, how I can imagine this is that in your prompt right here, let's say system message, you can say for every response I have, do not make a similar response, or do not make a similar employee profile as previous.
As previously generated.
Okay. Yeah, exactly. You can try that, right?
So what you're doing here in the chat playground, does that influence what the API is going to respond to, or is these two separate
Definitely.
things?
Yeah. Oh, right here, this system message. Yeah, this influences yeah, the type of responses that the chat dialogue.
Right, but if you then do an API call, is it using this configuration, or are they
Yeah,
two
yeah.
independent things?
So okay, so you go to view code, let's say, right? And so
Oh,
as part,
it's building a code view of how to configure how you want your API to behave.
yeah. So
Gotcha. Okay.
yeah. See, the thing is, this system message, it's going to be part of every single API call, right? Right. So you're going to say here, you are an IRS chatbot. So it's going to be part of every single API call. Okay. Um,
But
in
things like
ter-
the tone and temperature and things like that. I mean, you use the chat playground to build that. You get a configuration here, and then you feed that to your API to say, this is how I want the API to respond.
right. And
Gotcha.
also
Okay.
as part
I
of
just
your,
missed that connection there. Okay.
yeah, as part of the system message. And you know what, I made some, I played around with this before. You can say like, let's see here, each employee profile would be in a format of, let's say, name, and then name, and then whatever, like bio, and then you have something bio, and then you would say, and I've done this like in different situations where bio is X, and then you're saying name is, first and last name of, whatever, like
Yeah,
Western
I don't
world
need it to
people.
generate the whole structured profile. It's really just to generate the free form bio information.
Right, yeah. But I'm just trying to convey kind of how powerful it is, like by, you can influence the formatting of it,
Right.
and saying bio name, like is, yeah, like etc. What I mean? In terms of memory, you know what? Now I'm really not sure how, if it could remember, because let's see here. Because as you see here, right, like they are, from what I understand, they are independent calls. You know what I mean?
So they're
Um,
not aware of each other the way
yeah.
follow-on
Like
questions in a chat
I,
session are.
I feel like, okay, I feel like in this, it could be related, right? You're building context, but maybe the programming is done, like the code is done in a way where it has some memory functionality, where this is just bare bones. This is just how to make an API call. Okay.
Right.
Now there's something, and I'm trying to get into it, right? There's something called like LangChain, right? Like it's a framework. Um, and so like it has capabilities of, doing memory. You know what I mean? Right. So it's a framework of, like, okay, how to do document chunking, putting, text splitting, put the documents together, how to ask the question on a document and be kind of that chatbot, right? And even like say, okay, for every question, call out to the internet and try to find a list of, cite the reference, like the links, etc. You know what I mean? So this is where you can get very custom, and at a very high level, it has some capabilities, right? But it's not like out of the box capabilities. Like you have to, I would imagine you have to find some module. You have to code out how memory works. You know what I
Right.
mean? It's just a framework, right? Like how to piece everything together, right? A development
Okay.
framework. And so probably trying to answer your question about how do you manage memory, yeah, like maybe when you do a prompt, you get a response, you got to store that as a vector into a vector database, right, or a cognitive search or whatever, right? And then when you prompt again, right? It's going to go against that memory store, you know, along with some responses and maybe compare, right? Or if maybe in your LLM application, it detects that, you know what, this is not a good response. It didn't really attribute to the memory, so regenerate again. You know what I mean? So
Right.
it's all these like very custom things that you can do um, for that, which is really sounds really cool and exciting, right? So really building upon what I just showed with the embeddings, right? So it's this part right here, right? You go embeddings models, right? Okay, where do you store those embeddings? Well, you store them in vector stores, like cognitive search, right? Okay, now let's say I want to do like real PDF documents, right? How do I load those documents, transform them, you know, chunking, retrieving, all that stuff, right? And then you keep on building it on, building on top more functionality, which LangChain helps with, right? So this is how you know, you can build those, you know, like I guess the holy grail of generative AI in the corporate world, right? That we want to see, like the co-pilots and you know, private documents or the chat GPT of company X of Contoso, right? It's really like stuff like this, you know.
Right. Cool. Thank you.
Okay, cool. Yeah, anyone else? Any curiosities or what they're trying to work with or okay. So yeah, like let's see here. Do I have any conclusion slides? So that's that. There's other topics, but you know, yeah, the next steps is you really learn Python, you know, vector databases, cognitive search or Pinecone is another one, and then learn like LangChain. Semantic kernel is the other one. It's more of a very more Microsoft oriented, where LangChain is very kind of open source, but I think LangChain is more popular as the go-to, right? So this is how you kind of build on it, right? So, you know, with SharePoint, you know, with being a document store, I don't know. It seems a little tough to do like chatting against SharePoint data stores like in real time, right? There has to be a lot of ingestion and processing and yeah, with that, and also how do you do like what do you call it, security trimming, right? You know, the good old security trimming problem. So okay, cool. Well, anyways, that concludes my presentation, and yeah, I'll hand it over to you, Peter.
Cool. Very interesting. Thanks, Roy. Other thoughts, feedback? Well, Roy, if I get stuck, I might reach out to you to say, hey, can you give me a hand at least getting this started? But thanks again for a great presentation, and
Yeah, sure.
thanks everybody for joining in.